1.2 kind of finishes up our geometry section. It says that parallel lines are lines that lie in the same plane and do not intersect. Do we remember parallel lines?
Wow.
Yeah. A transversal intersecting the parallel lines forms 8 angles indicated by the numbers. There is a bunch of relationships between these angles and each other. Ooh, we are so hyper today. Can we calm it down just a little bit? Okay. The first relationship is called vertical angles. What are vertical angles?
Angles that are up and down.
Okay, they make like bow ties, is how I like to think about them. So, angles number 1, which one is its vertical angle? 4. How about 2?
3.
How about 5?
8.
How about 6? Great. These angles are congruent, meaning they are the same measurement, both 1 and 4. How about alternate interior angles? Alternate meaning opposite sides of the transversal. Interior means inside the parallel lines. So if this is number 3, what is the other alternate interior angle? 6. How about 4? 5. Alternate sides of the transversal inside the parallel lines. Those angles are also congruent. How about alternate exterior angles? 6 and 7 are vertical angles. 1 and 8 are alternate exterior angles. What's another pair? 7 and 2. So alternating sides of the transversal outside the parallel lines. Those are also congruent. Look at that. All these congruent things.
Is that pink or purple?
A pink. Consecutive interior angles. Consecutive meaning same side of the transversal, interior inside. So if I highlighted number 3, what is the consecutive interior? 5. And what about 4? These angles are not congruent. They are supplementary. Reminder, what does supplementary mean?
They support each other.
They sum to they support each other? They add to 180. Yeah. They support each other. That's cute. Okay. Consecutive exterior angles. So again, same side of the transversal, outside of the parallel lines, which would be 1 and 2, and these are also supplementary. Corresponding angles are angles that are in the same position at both intersection points of the transversal. So what is in the same location as 1? What is in the same location as 2? How about 3? How about 4? Those angles are complementary. Congruent. Said the wrong C word. Congruent. So there's a lot of relationships in these sorts of systems that you can use to solve problems. For example, we're going to find the measures of angle 1, 2, 3, and 4, given that lines M and N are parallel. So if we know that these two lines are parallel, what do we know about angles 1 and 4? They're the same. They're congruent. So mathematically, we would write angle 1 is congruent to angle 4. Algebraically, that means that 3x plus 2 should be equal to 5x minus 40. Our algebra skills are coming back in. We see that this is a multiple step equation, linear equation to solve. We would subtract 5x from both sides. We get negative 2x. We would subtract 2 from both sides. We get negative 42. Divide by negative 2 on both sides. We end up with x is equal to 21. Now that is a piece of information I need to then use to solve the questions. If I know that x is equal to 21, that means that angle 1 is equal to 3 times 21 plus 2. What's 3 times 21? Plus 2? 65 degrees. Make sure you put the degree symbol at the end or else it will be wrong. If angle 1 is 65 degrees, what's angle 2? Angle 2? How are they related to each other? Minus 180. They are supplementary. Very good, because they make a straight line. So what is 180 minus 65? Yes, 115 degrees. Awesome. Because 1 and 2 are supplementary. They make a straight angle. How about angle 3? What is angle 3? 65. Why is it 65? Because it's congruent to 1. They are vertical angles. And what about angle 4? How come? It's congruent to 1. What is their vocabulary word? Exterior. Is it alternate or consecutive? Alternate, opposite sides of the transversal. It is also corresponding with angle 3. So you could use either relationship to get angle 4. So some more vocabulary / geometrical ideas that we need to remember. Triangles, they add up to how many degrees? Triangles add up to how many degrees? 180. We need to know that. That is a fact that we need to know. It's called the angle sum of a triangle theorem. If we apply that theorem, it says the measures of 2 of the angles of a triangle are 48 degrees and 61 degrees. Find the measure of the third angle x. I like in almost all of these problems to draw a picture because I'm a visual person, visual learner. So let's say we have this triangle. You don't have to draw it to scale. Thank you so much. We have 48 degrees right here and 61 degrees right here. It's not drawn to scale. Just let you know that. If we know that all of the angles in a triangle have to add to 180, what can I do to solve for that missing angle? 48 plus 61 is how much? 109. And then 180 minus 109, 71 degrees. So that means that x is 71 degrees.
Yay.
Easy peasy, yes?
Yes. But it's gonna get harder.
Obviously. Section 1.2, guys. So vocabulary that I'm going to use throughout this course. An acute triangle means that all of the angles are less than 90.
Okay.
A right triangle means that one of the angles is 90 degrees. It will be marked with a box. An obtuse triangle has one obtuse angle and 2 acute. Those are the types of triangles you can have classified by angles. If we're classifying triangles by sides, a triangle that has all equal sides is called an equilateral triangle, equal sides. An isosceles triangle, I like to think of them as ice cream cones. Isosceles ice cream.
Oh, yeah.
2 of the sides are the same and 1 is different, so it's like a little ice cream cone. And a scalene triangle means that none of the sides are congruent. Scalene. Some more theorems that we need to know is about similarity and congruence. If 2 triangles are congruent, that means that they are the same size, shape, and angles. They must be similar. However, a similar triangle does not necessarily mean that they are going to be congruent, because similar triangles are similar if the following 2 things happen. This is in a little exclamation point box. If the corresponding angles have the same measure and the corresponding sides are proportional. They don't have to be the exact same, but they have to be proportional. So the angles are the same and the sides are proportional. That's what it means for something to be similar. So we're going to be able to set up proportions and solve with cross multiplying and dividing. That's for a similar triangle. Congruent means they're straight up identical copies of each other. So if you look at the theorem box, we have some examples. These are obviously not the same size, but since their angles are all marked to be the same, they are similar, but they're not congruent. For this one, again, the angles are all marked, which means they are similar but not congruent. These ones, they're not marked, but we can mark them because that was the intention here. So we're going to give 1 tick mark to this guy, 2 tick marks to this guy, and 3 tick marks to this guy, indicating that these triangles are congruent because they have not only the same angles, but the same sides. All of these triangles are similar, but only the last one is congruent. All of those triangles are similar, meaning their angles are the same, but their sides are proportional. Just the last one, though, gets a step further, and it is also congruent because they are the exact same. Okay, let's use these concepts to do 3 more problems for the day. We're going to use the triangles ABC and NMP and the similarity between them to find the unknown angle measures. Now here's what's important. The order in which it is written is the order in which they correspond to each other. So A, B, C, since A and B are connected, that means that N and M are connected. I shouldn't have drawn those lines. I'm so sorry. They're not congruent. I'm just saying that those are the same lines. Let me just highlight them in this color. How about that? These are going to be proportional. MP is the next letters, which means BC is also proportional. CA, last letter to first letter, and PN, last letter to first letter, are also proportional. This will help us later when we're really trying to find these similar triangles. Now, obviously for us, angle A is marked 45 degrees. Angle N is marked 45 degrees. That's great because they're similar. If angle P is 104 degrees, what's angle C?
104 degrees.
Very good. So we can say with confidence that angle C is equal to 104 degrees. All that's left that's unknown is angle B and angle M. How can we figure out what angle B and angle M are? Add 104 and 145, so 104 plus 45 is 149. And then what? Subtract it from 180. 180 minus 149 is equal to 51. Nope, 31. Which means angle M is 31 degrees. And angle B is 31 degrees because those are corresponding angles in the triangle. They are marked to be congruent. In example 4, we're given triangle ABC and DFE, and we're told that they are similar. And this time we're going to find the unknown sides of the triangle. So let's make sure we understand how these things are connected. If we go A, B, C in that order, we're going from A to B and D to F. The letters that they gave me are ordered that way on purpose. Then I go from B to C and F to E. That side will be proportional to each other. Last letter C to first letter A, last letter E to first letter D. Those sides are proportional. Everybody loves proportions, so let's get into it. We always need to use the sides that we know both pieces of information for. So do we know all the information for pink, blue, or green?
Pink and blue. Green.
Green. I know the numbers for both triangles on the green sides. So I'm going to use 16 over 8 for both of my proportions. 16 over 8 is going to be equal to, let's do the blue side first. Why not? What number should I put on top of this fraction?
32.
And what would I put on the bottom? X. We're going to cross multiply and divide. 8 times 32
Is a big number.
is, I didn't actually do this problem, 256 equal to 16x. I did this problem differently, I guess I should say. 256 divided by 16 is 16. So that means that the blue side, which is side FE, would be equal to 16. We use this same process, same idea with the same given information, which is the green side, and then the pink side. So this is going to be 24 over x to solve for the pink side. 24 times 8, that's 32, 192, equal to 16 times x. Divide by 16, that's 12. Which tells me that angle DF, not angle, so sorry, side DF is 12. Yes?
Can we just
100%. If you notice that it's scaled by a half, yes, 16 divided by 2 is 8, 32 divided by 2 is 16, 24 divided by 2 is 12. It just won't always be that pretty to be a number like 1/2. Sometimes it'll be other decimal proportions, so I wanted you to have the steps for real. That's how I did it on my paper, but these are the easier steps to take when the problem gets more complicated. Okay, last but not least, finding the height of a flagpole. Workers must measure the height of a building's flagpole. They find that the instant when the shadow of the building is 18 meters long, the shadow of the flagpole is 27 meters long. The building is 10 meters high. Find the height of the flagpole. What's happening here? Great question. So here we have a building, and the building casts a shadow on the ground. The instant that when the shadow of the building is 18 meters long, the shadow of a flagpole, here's a flag. Ta-da! It's supposed to be a Texas flag. It's not art class. I know it's not.
It is art class.
Wait, it's super not right. Let me fix it. Not that many stripes. You're so right. Let me fix it.
Yeah. Yay.
Is the red on top or bottom? Oh, there's a flag right here in the classroom. I promise I lived here my whole life, guys.
Okay.
Is that better? Anyways,
No.
how high is the building?
10.
I'm embarrassed by my drawing skills. It's fine. We have 10 meters,
I see you did
18 meters, and then 27 meters. Here's why this problem can be answered using similar triangles. If we drew a triangle that went from the top of the building and the top of the flagpole to the end of the shadows, we now have a similar set of triangles. We have our 90 degree. We have the same angle of elevation from the ground or angle of depression from the top of the image. So these are similar figures. So to find the height of the flagpole, we can just set up a proportion like we did in the problem above. So I'm going to put the one that we know both of. What do we know both of? Is it the height or the shadow? Shadow. I'll just put the building first because why not? This is going to be 18 over 27. Since the building went first, what number do I put on top? 10, and I put the height or the x that we're looking for on the bottom. 27 times 10 is 270. 18 times h is 18h. Divide 270 by 18. The height is 15. So we would answer, because we're all about units, 15 meters. If units are given to you, units are required at the end.